now let's answer another question that that was first answered by Archimedes, around 2,000 years ago. And that question is, why do things float? So imagine we have a fluid, something like water, and then we have, some kind of oddly shaped rock, inside of it. So if we were to look at all of the forces on this, we know that basically you're going to have water coming from all sides, trying to get into this vacuum, into this space where the rock is, right? You're going to have water pushing it from everywhere. Okay, so let's say that you were to take the rock out and just leave a vacuum here. So all we have is an empty space. And then we were to sum up all of the forces, coming from, from all 360 degrees, we would see that there's going to be a net force that goes directly up. It's not going to be moving right at all, not going to be moving left at all. All of the left-right forces are going to cancel each other out perfectly. And we're going to be left with the net force up, which we call the buoyant force. So this is the buoyant force. Okay? So this F net is going to be the mass. So the buoyant force is the mass of the displaced fluid times G, or the density of the fluid times the volume of the fluid. The volume, so V would be the volume of this fluid, or the volume of fluid we displaced. So this is the displaced volume. In other words, if I put a rock in here, the rock's occupying that space, so water isn't. So I had to displace water to put the rock there. And so this volume of the fluid, this is telling us how much, this is the same thing as the volume of the rock. It's telling us how much water we had to move to allow the rock to be there. Okay? So now if we look at the rock's mass as well, we see that we have the mass of the rock times G going down, and then the mass of the fluid times G going up. Right? So our net force is going to be minus mass of the rock times G plus the mass of the fluid, times G, and that's going to equal the mass of the rock times its acceleration. Right? So we know if A, the magnitude of A, is greater than or equal to 0, then that's telling us that that the object floats. Right? Because it's saying that we have a net force that's up, and if our net force is up, then that means it floats. However, if A is less than 0, then we know that it sinks. Okay, so now, so let's say that I have a rock with some volume V. Okay, so so we know that it's going to float if A is equal to 0. It means that the buoyant force and the gravitational force are perfectly balanced, which means the mass of the fluid times G is equal to the mass of the rock times G. So the mass of the fluid equals the mass of the rock. Well, mass is just density, so density of the fluid, volume of the fluid, is density of the rock, volume of the rock, which is also the same as the volume of the fluid. So it says that their densities are the same. So if we have, this is probably something you remember from like high school chemistry, that if we have a fluid that's more dense, then then it's going to sink. But if the density of the object is less than the density of the fluid, then it's going to float. And so this is Archimedes' principle, and this is really kind of the end of this unit. You'll have problems just applying this to other physical problems that you'll see. And so what we've really done in this unit then is we've added a new force, and that new force is the buoyant force, that's equal to the mass of the fluid that's been displaced times gravity.